Hello guys, welcome to Ramta Solutions. Today we are going to prove proportion theorem. Okay, we're going to prove proportion theorem, or others prefer calling it proportionality theorem. It's okay. Right, so at the end of this video, you'll be able to prove this. Okay, so without any waste of time, let's start. So, with proportionality theorem, it says a line drawn parallel to one side of a triangle divides the other two sides in the same proportion. I will give you some time to be writing all these things that you have on your screen. So then, having said that, whenever you use this theorem, you will say a line drawn parallel to one side of a triangle. Okay, of a triangle. Okay, so this is your reason. Whenever you use this theorem, you'll be saying a line parallel to one side of a triangle, or simply line parallel to one side of a triangle. If you like, you can also say proportionality theorem or proportion theorem. That's another way of using this theorem. Okay, perfect. So when we use, or rather, when we prove proportionality theorem, let's say we are given, like we had in the opening slide, given triangle ABC with line DE parallel to BC. Let's see. Given triangle ABC with line DE parallel to BC, right? So I'm going to draw different triangles, of course, including the one that we had in the opening slide. Let's think of this triangle here. Let's call it A, B, C, D, E. Remember, we are given triangle ABC with line DE parallel to BC. As we can see, DE is this one here. It's parallel to BC. Or you can also draw it like this. A, B, C, and call this one here DE. Okay? Remember, information given is that line DE is parallel to BC. Or alternatively, you can have it like this. Alternatively, you can have it like this. Let's maybe call this one here ED and call this one here BC. Maybe let me restart it, because right now it doesn't look like it's, yes. Yeah, that's better. Yep, that's better. So let's call this one here ED, and then we call this one here, this point, let me call it A, and then we call these ones here B and C. Now, remember we have said DE is parallel to BC. This is DE, it's parallel to BC. Okay, it's parallel to BC. So now note, proportionality theorem or proportion theorem says a line drawn parallel to one side of a triangle divides the other two sides in the same proportion. All right, we are going to see this. Remember, when you use this, you can say line parallel to one side of a triangle when you use this theorem. Okay, now the proof that's required, the question will say prove AD over DB is equal to AE, is equal to AE over EC. Okay, that's the proof. We need to prove this. Okay, we need to prove this. All right, so let's get into it. Let me give you at least 20 seconds for you to finish drawing this. Okay. Okay. So yeah, this is one of the nicest theorems that you can come across. It's nice and easy. It'll give you marks, I guarantee. All right. Now, let's proceed. Now, proof. I'm going to use, which triangle should I use? Maybe let me use this triangle here. Okay, maybe let me use this triangle here. But it doesn't matter. It doesn't matter whichever you use is okay. But I'm gonna use this one here. Okay, I'm gonna use this one here. I like this one. Okay, so whichever you use, you're still gonna get the same thing, but I'm gonna use this one here. So let's see. So let me draw the triangle. It was point A, D, A, B, C. Okay, so what you're going to do, first thing first, write the statement, of course. Draw H1. Sorry, I like saying HI. Draw H1 from where? From E, which is perpendicular to, and make it perpendicular to AD. Right? Perpendicular to AD. And H2 from D perpendicular to what? To AE. Can you see that? Now, let's do it. Let me perhaps use a line here. I want to use a line, make it thin. Okay, fine. I'm going to use a line here. Okay. And then I'm going to use another one here. Remember, we have set perpendicular, right? We have set perpendicular. So this is the line, it's perpendicular. So this line here, we called it H1, while this one here, we called it H2. Okay? We called it H2, right? As you can see, draw H1 from E, here is it, perpendicular to AD. Indeed, perpendicular to AD. Can you see that? And then H2 from D, perpendicular to AE. Here is it. Can you see that? Perfect. This one is H2. All right. Perfect. Now, proceeding. We're going to draw. Now we're going to draw BE and CD. Okay, we're going to draw BE and CD. Okay, I'm going to draw them again. Let me return them. Here they are. This is BE. Can you see that? Now let's draw this CD. Here is it. Can you see that? Perfect. So these now are the conditions, or the steps we needed to start with. Now let's proceed and get into proving this theorem. So I want you to compare this. Now we're going to use the areas. I want you to use area of triangle ADE and compare it with area of triangle BDE. Okay, and compare it with area of triangle BDE. Let's look at triangle ADE. It's this one here, right? It's this one here. Now, I want you guys to remember something. As in the previous video of areas of triangles, I mentioned that you draw, the height is always relative to the base that you choose, right? So here, the base was AD, right? So now remember, area of a triangle is half base times height. What is the base? It's AD. What is the height? The height is given, it's this one here, it's given as H1. Right? Proceeding, triangle BDE. BDE is this triangle here. What is its base? Now, before that, I want you to remember we're looking at triangle ADE and triangle BDE. When you look at it, they share the vertex. Now, triangles that share a vertex have a common height. So if they have a common height, it means your perpendicular height will be here, right? So this means BD will be, or rather DB will be your base. And then what is the height? The height is H1. Now, as you can see, half cancels with half, height cancels with height. What are you left with? You are left with AD over DB, right? You are left with AD over DB, right? Now, proceeding, you have, let me see, okay, proceeding, we will then look at another relationship. I'm still going to take area of triangle ADE, but this time around, I'm not taking triangle BDE. I'm going to take triangle B CED, this one here, right? Okay, triangle, area of triangle CED. And by the way, I forgot to put the parallel lines here. Remember, if a line drawn parallel to one side of a triangle, so there's supposed to be parallel lines here. So what is area of triangle ADE? It's still half times. What is the thingy? What is the base now? Remember, ADE, when we compare it with CED, look at it, this one here, when we compare it with CED, we're no longer considering height H1, we're considering this height here, which is H2. Can you see that? We're considering this height H2. So what is its base? It'll be AE. So it's half times AE times, what is the height? It's H2 over half times CED. CED, as you can see, CED and ADE, they share a common vertex D. Now that they share a common vertex D, it means they have a common height H2, right? It means they have a common height H2. So this means the base will be AC, right? So the base is AC times, what is the height? H2. Again, height cancels, halves cancel, height cancel. What are we left with? We are left with AE over DB. Okay, you are left with AE over DB. Now I'm going to show you something. Do you see that when you look at triangle BDE and triangle CED, when you look at them, they lie between parallel lines. And since they lie between parallel lines, they also have, since they lie between parallel lines, they will also have common height or same height, and they will also have common base. What is their common base? DE. Can you see that? They will also have common base DE. That's if you draw their height like this, right? This is a video that we did in the previous video where we spoke of areas of a triangle. This is something that we proved. So I repeat, I'm going to draw it separately just so you can see. So here we are. We had right. So this was D and this was BC. All right. This was BC. All right. So we're looking at this triangle here, and obviously these lines are parallel. right? The height will be common for both. And if you were to draw the height, it doesn't matter how you're drawing it, it's the same. Okay, it's the same. Or maybe let me just do it like this. Yeah, height is the same. Doesn't matter, height is the same. Right? Height is the same. So the height of these two triangles, is the same. They share a base DE. I don't know if you guys can see it. They share a base DE. So if that's the case, the two triangles, their areas will be the same. Let me remove it. Their areas will be the same. So therefore we say, oh boy, let me use that. So area of triangle BDE is equal to area of triangle CED. Why? Because they have equal base and height, right? They have equal base and height, right? So if that's the case, we can therefore conclude and say, okay, so this means area of triangle ADE, right? Area of triangle ADE over area of triangle BDE is basically equal to area of triangle ADE over area of triangle CED. Right, can you see that? Area of triangle ABD, ADE over area of triangle BDE, and area of triangle ADE over area of triangle CED. What was area of triangle ADE? It was over BDE, it was AD over DB. So here is it. It was AD over, therefore, over, is it AD? Or is it AD? Oh yeah, AD over DB, AD over DB, right, is equal to area of ADE, triangle ADE over triangle CED. What was it? AE over DB. Is it so? Oh, my mistake. I see I made a mistake here. It's not DB, it's EC. My mistake here. It's EC. It's EC. All right, it's EC. So this is it's EC. Yes, so it's AE over EC. Right? It's AE over EC. Let's see. What were we supposed to prove? We're supposed to prove that AD over DB is equal to AE over EC. So let's see if we were able to prove it. Yes, AD over DB is equal to AE over EC. Okay? Now, this is a proportion theorem. This is proportion theorem, and this is how you get to use proportion theorem. So I will then tell you that generally using proportion theorem, from proportion theorem, this is what you need to know. From proportion theorem, let's say we have this guy here. Yeah, let's say we have this guy here. Let's call him A, B, C, A, E. What you do know, you can say we prove that AD over DB is equal to AE over EC, right? Over EC, right? Again, you can still say this is also equal to AC. Let me try it in this way. You can also say A, for example, AD over AB, I want you guys to pay attention, AD over AB. You can also say it's equal to AA over AC. Can you see that? So if you take on one side of your ratio, if you take this over this, the one that you compare with must also be this over that. Okay? For example, we took AD over AB. As you can see, it's this part over this part. It must be this part over, it must be equal to this part over this. Okay? Similarly, you can also say AB over perhaps BD. It's okay, AB over BD. You can also say it is equal to what is AB. It is equivalent to AC. So you can say it's proportional to AC. And then BD, what is it proportional to? It's proportional to CE. Right? It's proportional to CE. So this is how you use your proportion theorem. Okay? This is how you use your proportion theorem. Okay? All right. Now, let's look at its converse. We are not going to prove the converse. Okay? We are not going to prove the converse. We are just going to take it as it is. Okay? Or maybe I should also add, before I leave this one here, I should also add, there's basically a lot that you can do pertaining this, right? There's basically a lot that you can do pertaining this, but it's okay. I will just leave it as it is, so it's fine. Let's proceed. So converse of proportion theorem, we're not going to prove it, okay? We're not going to prove the converse, okay? So what we are going to do now is that the converse says, okay, the converse says, of course, this is not for your exam, so this is why I'm not going to prove it, okay? But I will make a video of this proof later. So converse says, if something you should know about a converse is that it is the reverse of the theorem. So remember, the theorem said a line drawn parallel to one side of a triangle divides the other two sides of the triangle in the same proportion. Now let me show you what a converse says. So a converse says, check, if a line, this is the statement, if a line divides, check this out, if a line divides two sides of a triangle, write it down, two sides of a triangle, okay, in the same proportion, then the line is parallel to the third side of the triangle. Like, you guys know what is this by now. It's parallel to the third side. Right? It's parallel to the third side. Right? It's parallel to the third side. So if you recall, your proportion theorem said a line drawn parallel to one side of a triangle divides the other two sides in the same proportion. You see, now we're moving backwards. If a line divides two sides of a triangle in the same proportion, then the line is parallel to the other side. Oh, sorry, the third side. Let me put this third side to the third side. Okay, to the third side. Okay, to the third side. Okay, so now when you give your reason when using this converse, you can say its line divides sides in proportion. Divides sides in proportion. Or simply, you can say it's converse prop theorem. It's okay. All right? Or simply, you can say it's converse prop theorem. Okay? So this is your proportionality theorem or your proportion theorem, guys. And this is how you prove it. Okay? This is how you prove it. Remember the basics that we applied here. If you are not familiar with them, you can go to the previous video before this. I think we will leave it in the description. Okay, so you can check it in the description below. On your video on YouTube, you can check the description. We will try to leave the link to that video. Okay, so with that being said, it's a wrap and bye-bye.